Modern front-end development is about components. Whether we are building an application in React, Vue, or Angular, components are the abstractions that we build our user interfaces out of. Today this seems obvious, but if you think back 5 years ago, front-end development was much more chaotic. And this was partly because we had not settled around this terminology of the component. React has become the most popular front-end framework, and part of its growth is due to the ease and reusability of components across the community. It's easy to find building blocks that you can use to piece together your front-end application. Do you need a video player component? Do you need a newsfeed component? Do you need a profile component? All of these things are easy to find. As you build a React application, you take open source components off the shelf and you build some other components yourself. To keep things looking nice and consistent, you need to style your components. If you're not careful with how you manage your style sheets, you can end up with inconsistent stylings and namespace conflicts. Max Stoiber is the creator of Styled-Components, a project to help enforce best practices around styled components. He is also a founder of Spectrum, a system that allows people to build online communities. Spectrum has similar design and engineering challenges to Slack or Facebook, so it made for a great discussion of modern software architecture. In today's episode, Max and I had a wide-ranging conversation about front-end frameworks, components, and the process of building a product. Max also describes the advantages of using GraphQL and the Apollo toolchain. G2I is a talent platform built for engineers by engineers. React Native, React, and mobile. The developers on G2I have expertise in the best tools to build your applications. When I need engineers to help me out with my apps, G2I is the first place I go, especially when I'm building with React or React Native. Contract a G2I developer to help you on a short-term basis or hire a G2I developer full-time. And if you're looking to build cross-platform applications in React Native, definitely check out G2I. The G2I platform is a community of React Native, React, and mobile developers, and these engineers can become part of your team. If you're looking for developers to build your product, check out g2i.co. That's the letter G, the number 2, i.co. You can also send me an email, and I'll be happy to tell you more about my experience with G2I. Find your React Native, React, and mobile talent by going to g2i.co. And thanks to G2I for helping me ship my products, and thanks for becoming a sponsor of Software Engineering Daily. Max Stoiber is a React.js developer, an open source maintainer, and the founder of Spectrum. Max, welcome to Software Engineering Daily.
Hey, Jeff. Thanks for having me.
I want to start by talking about a project that you're well known for, which is called Styled Components. And in order to talk through this, I want to first start with the idea of the component. We've gotten to this place in front-end development where the abstraction that we build our applications out of is the component. How do you define a component?
A component, for me, is really an encapsulated piece of user interface, I think. In the sense that, similar to how you would use Lego blocks to build, huge buildings, it all starts with that one tiny block. And the component is sort of the most minimal version of a certain piece of user interface. And then we take those components and build them up to complex systems. And what's nice about components is that it becomes easier to understand the system as a whole. Because since we have all those small encapsulated pieces that are relatively easy to understand, by understanding all the small pieces, we can more easily understand the whole system. Where if you, on the other hand, if you were to write spaghetti code and like one huge ball of mud, right? It becomes really hard to understand because you'd have to understand the whole system before you could even begin to understand the small pieces. So yeah, I would say that's what I would call a component, an encapsulated piece of user interface.
Right. And how did we get here? You deal with components today, and it feels so intuitive. It's hard to imagine how the world used to be, but it did tend towards spaghetti code in many front-end projects. What were the abstractions that we were using before components?
I think the web's always moved towards components. They just weren't always called components, right? Even in something like PHP, which has been around for ages, you'd have these includes, which are kind of like encapsulated pieces of user interface, right? And you just include a button.php, for example. I think what's changed is the focus on building a foundational set of components, right? Previously, you just ad hoc create components wherever and have, hundreds of thousands. But then if you have that many components, it becomes ununderstandable again and kind of a huge ball of mud again. And so what's shifted, I think, is the mentality from these. We did have sort of encapsulated pieces of user interface, but they were very big. And I think the big mindset shift has been to, narrow them down in scope and start with really tiny blocks rather than medium or large blocks. Yeah, I think even something like Dojo had, I can't remember what it was called, but they also had modules or components or something to that effect. And Knockout and Backbone all had a similar concept to components. It's just that in my mind, they were a lot bigger, right? It wasn't that you created a component for a button. That was kind of not very often seen. It was too easy to just render a button rather than create a button component that you reuse throughout the app.
Okay, you mentioned a couple best practices there, basically starting with very small components. What are some other best practices around building applications around components today? I
think the most important really is keeping a consistent set of them, because still today it's very easy to just create a huge, in React would be called a component, but will really be a view out of, with 1,500 HTML tags. But ideally, each one of those HTML tags would be its own tiny understandable component, but then you also end up with 1,500 components. That's also not ideal. So you have to sort of define a design system of components that you reuse throughout your app. And by having that sort of very narrow, small set of base components that are very extensible and very flexible, you don't end up creating a ton of complex logic, right, and a ton of ad hoc HTML nodes. I think that's really the most important thing in what the industry has moved towards. It's just that sense of a component library or of a design system or pattern library, whatever you want to call it. Just some base set of components that lives separately from the app. And then style components sort of, the reason we made the library the way it is because for us, we used components for everything, right? Glenn and I, we had components, for example, a grid. Rather than rendering a div class equals grid, like you would do with Bootstrap, we would have a grid component, which would maybe do the same thing, right? Maybe that grid component just renders div class grid under the hood. But really, I don't want to have to care about that, right? I just want to have that set of components, and one of those components just happens to be a grid that I can use to lay out my app. What exactly that does is, while building the app itself, while layouting sort of everything consistently isn't really what I care about, right? I only care about making everything consistent. And then if I want to change the whole layout of the whole app, I just change my grid component. And so style components sort of came from that philosophy of using components for everything and having components be responsible for styling. And I think that works out really well, especially in React.
There's a related term called a container when it comes to front-end development. What is a container in the context of front-end development?
The differentiation between a container and a component sort of came from an article that Dan Abramov wrote, must be 3-4 years ago now, I think, which is basically just a pattern of having two different types of components, where one component is responsible for the styling and the rendering of text and the rendering of HTML nodes, and the other component is mostly responsible for data fetching. That sort of model where the one that data fetches is a container, right? It's something that fetches some data from an API and then renders smaller sort of components that just care about rendering something. The nice thing about that is that you end up with these small components that just care about rendering, which are easy to test and easy to verify they work as they should. And all of your logic lives in these containers, which themselves only care about fetching data and manipulating data and don't really care about the stylistic aspect of your app, which makes everything much more understandable, because if you have a bug, you can very easily figure out where the bug is, right? If you have a bug where an item that was loaded from the API isn't displayed, then you know the bug must be somewhere in the styling. Or if the API returns the right data, but then the container changes it wrongly or handles it wrongly, then you also know where that bug is. And it's sort of, it got taken a bit, I personally think that article gets taken a bit too much as gospel and as a rule rather than just a nice pattern to use when you have to fetch lots of data from an API. Where that is sort of taken to the extreme recently was GraphQL, where most GraphQL libraries that you use with React have their data fetching be based on components. And that works out really well because GraphQL then basically abstracts your entire data fetching logic, right? You don't do any of that. You just say, your component just says, I want to have the current user, their username, their age, and their profile picture. And it doesn't really care where those things come from. It just tells GraphQL to get them, and GraphQL gets them, which works out really nicely for building the front end because it makes everything sort of very streamlined, right? You don't even have to call an API yourself. You just say, I want to have this data, and then that data is there.
What else is going on in the movement towards GraphQL on the front end? How does somebody refactor their front end application to use GraphQL? That's
a good question. I think the first step is that you need to have a GraphQL API, which I think is actually the harder part in the sense that not a lot of, or that's not entirely true, but I think front-end developers are more open to GraphQL because it really makes their lives easier, right? As a front-end developer, using GraphQL is a joy. I don't want to write an app where I have to manually orchestrate 5 different fetches and then end up overfetching data or underfetching data. And with GraphQL, you just never have to worry about that. It does increase, or it can increase if mismanaged, the complexity of a backend quite a bit, though. So the first step would be to convince your backend developers to write a GraphQL API. Once you have a GraphQL API, refactoring to use GraphQL it depends on how well your app was architected from the beginning, right? If you have those sort of set of base components, that if you have that container component split already, are relatively strict about it, then not much is going to change because your sort of stylistic components are still stylistic and they still get the same data. And then rather than having containers, you just have GraphQL queries. So that works out quite nicely, I think. I've never done it, though. I've never refactored an app from a REST API to a GraphQL API.
We'll talk a little bit more about GraphQL later on. Let's talk about styling and emphasize the component side of things rather than the data fetching side of things. So, we've had CSS for a long time, and we've had components for a long time, as you alluded to. Whether or not we've been calling them components is up for debate. But the best practices around styling our components have certainly changed over time. It's 2017. What are some best practices around styling components today?
The big differentiator to 2016 is that many people now use this concept of styling components, not necessarily with styled components library, but just styling components where you have a grid component or layout components that just render some stylistic thing, whatever that might be. And the second big shift in sort of at least the React ecosystem has been to write your CSS in JavaScript rather than in separate CSS files, which styled components also does, or lets you do, I guess.
Right. Before you built this project, Styled Components, what were the shortcomings that you saw in how people were managing their styles?
So I'm going to sort of answer this question in a very roundabout way. People, when they see something like CSS in JS library, sometimes go, why would I ever do this, right? CSS works perfectly fine for me. I don't really need to use anything else. Why would I use this? And then I go, if what you're using right now works for you, then that's perfect. Don't use anything else because, why change a running system? At the same time, the reason styled components and other libraries like styled components exist is because CSS wasn't invented for components, right? It was really invented for documents, for laying out long pieces of text, where today, with something like React, you probably aren't building a long document. You probably aren't rendering you might be rendering long pieces of text, but many people use it for more dynamic things, right? For dynamic applications rather than just rendering a document. And so CSS sort of has this gap between, it can work in component-based systems, but it requires a lot of work to get right because it has things like a global namespace, right? Every class name has to be globally unique, which is kind of hard when you have these encapsulated pieces of user interface, but then you have to assign them globally unique variables or names, basically. That just doesn't make any sense. And so the React community sort of went into this direction of, why don't we just not care about class names anymore, right? With the invention of CSS modules, class names were essentially just taken out of your hand entirely, right? You would have a build process like Webpack take your CSS and uniqueify every single class name so that you would never have a class name clash, which is super nice because it just avoids a whole bunch of bugs that you never want to have to deal with, right? I really have more important things to do than to figure out whether the class name I'm trying to use is globally unique or not, right? Why do I, as a human, have to take care of that? That's just, I'm not very good at it, right? I have to search through the entire code base and have to make sure that people don't use variables and stuff. And then it's just tedious, whereas a computer is really good at it because they can know which class names there are, right? They can have a global list of all the class names there are, and then they can make sure that they're unique. So why don't we let computers do all the stupid work and we can focus on the more important parts of our app, right? And that then got taken to an extreme with styled components where you don't even ever assign a class name anymore to anything. With CSS modules, you would still import class names from your CSS files. With styled components, you never ever see a class name, right? Or at least you shouldn't, depending on third-party libraries. When you write styled components, you never handle class names directly. You only write components which have a certain style fragment, a certain piece of styling associated with them, which is super nice because now I can focus on actually styling my app rather than having to focus on, well, how do I make my styles dynamic? How do I make a button primary? What's the overriding mechanism? How do I yada, yada, yada? You just render a button or a button primary, and that just looks either normal or primary.
For more than 30 years, DNS has been one of the fundamental protocols of the internet. Yet, despite its accepted importance, it has never quite gotten the due that it deserves. But today's dynamic applications, hybrid clouds, and volatile internet demand that you rethink the strategic value and importance of your DNS choices. Oracle Dyn provides DNS that is as dynamic and intelligent as your applications. Dyn DNS gets your users to the right cloud service, the right CDN, or the right data center, using intelligent response to steer traffic based on business policies, as well as real-time internet conditions, like the security and the performance of the network path. Dyn maps all internet pathways every 24 seconds via more than 500 million trace routes. This is the equivalent of 7 light years of distance, or 1.7 billion times around the circumference of the Earth. With over 10 years of experience supporting the likes of Netflix, Twitter, Zappos, Etsy, and Salesforce, Dyn can scale to meet the demand of the largest web applications. Get started with a free 30-day trial for your application by going to dyn.com/sedaily. That's dyn.com/sedaily. After the free trial, Dyn's developer plans start at just $7 a month for world-class DNS. Rethink DNS. Go to dyn.com/sedaily to learn more and get your free trial of Dyn DNS. To underscore this, to explain why namespace clashes often occur in CSS and how you are avoiding that with styled components.
Every person that's worked on any sort of big frontend or client-side, well, any big frontend really, has probably run into a bug where either yourself or some other developer or a third-party library uses a global class name that you've already used. And so then you have to figure out, how do I override this, right? How do I make it different? And so you have to either use important or you have to choose a different class name. But then when you have to choose a different class name, what do you choose? Because it's probably already a good name for what you're trying to do. So then if you have to choose a different name, it might not be the optimal name anymore. And it's all just super annoying, right? It's just a problem that you don't want to have to deal with, where your header overrides your button styling because it has a header button declaration. That gets even worse when you have nested class names, right? When you have high specificity, because then overriding might not even be possible. If somebody uses inline styles, you suddenly can't override it anymore. And so all of these annoying problems with CSS, you just don't have them anymore, right? It just gets rid of that entire class of problems by just not having you worry about class names at all, ever. I don't know if this makes any sense without having actually seen what it looks like, but it's very nice to work with.
Right. Let's describe that in more detail. So how does styled components work under the hood?
So what styled components does under the hood is you tell it which HTML tag you want, and you tell it which styling it should have, right? So for example, you could say you want to have a button HTML tag that is a color of red. And under the hood, styled components, the add component that has a certain automatically generated class name, and then it injects your color red declaration, all of your styles associated with that HTML tag, into a style tag with that unique class name. So all you ever see as a user of styled components is components, which is why it's called styled components. So you just see a button component, and that button component renders a button HTML tag with a certain piece of styling. And then under the hood, styled component sort of takes that, injects it into the head, and generates a unique class name that can't be duplicated. So you won't ever run into annoying bugs where some class names override each other or anything like that.
Mm-hmm. Maybe you want to describe some of the things that people are often confused about when you discuss styled components with them?
The biggest source of confusion is probably that people think it's inline styles, right? So a first wave of building more encapsulated CSS, or a first wave of inventions around building encapsulated CSS, were focused on inline styles. And so they would assign a style attribute onto tags and then pass the styles as a string. The issue with inline styles, of course, is that they're imperformant. When you render a large application with inline styles, it takes the browser a while to get through all of those inline styles. And then on top of that, you can't have media queries, you can't have pseudo-selectors, so you can't do hover styles or focus styles or anything like that. And it's just overall not perfect, right? And so when people first see styled components and see, hey, this encapsulated styling, they think, oh, this is another one of those inline styles libraries that generates inline styles. But I don't like inline styles, so I'm not going to use this. When really it isn't, right? We inject CSS into a style tag, meaning it's just CSS, right? There's nothing fancy about it. It's literally just CSS. You can use media queries, pseudo-selectors, whatever you want. Whatever you used from CSS, you can just use in styled components because it is just CSS. That's probably the number one confusion that people have. I actually wrote a blog post about this a while back, and people still ask me that question every other time and go, why would you use inline styles? And I'm like, no, it's not inline styles. So yeah, if you were thinking, I don't want to use inline styles, it's not inline styles.
Okay. Well, I'll put that confusion disambiguation article in the show notes of this episode. You know, I'm glad we got to talk a little bit about the styled components side of things and some of your beliefs around components and front-end development, because I want to use that as a jumping off point into Spectrum, which is a product that you have built, which allows people to build online communities. And I'd like to take a top-down approach to this and discuss first the product and then how you built it and how the architecture you built Spectrum out of reflects your beliefs around front-end development. So let's start with the product itself. Explain what Spectrum is.
With my open source projects like styled components, I always had this issue of I can't personally answer every single question of every single user that ever comes in. That's just too much, right? No maintainer of any popular open source project can do that. So you want to have a place where the users of your library can connect with each other and can answer each other's questions, so you have to do less work. The issue is that all of the existing places are very badly sort of optimized for long-form discussions, right? The most common tools are things like Gitter or Slack, but they all use IRC-style chat, where you just have one large chat room.
What about Discourse?
Or Discourse is a forum. So you also don't want to have a forum because then it's static again, right? You want to feel like you're a part of something. On Discourse, it's just how often times do you visit forums, right? Realistically. It's just not the same feeling as a chat room, right? So IRC chat is nice in some aspects. It's real time. You feel like there's warm bodies, right? You feel like there's people around. And forums also are nice because they're great for long-form discussions, right? When you talk about something more in depth that sort of has a space, a forum is great for that. Where IRC chat is horrible for that because people are there and there's 5 conversations ongoing at the same time and it just scrolls up and up and up. And if you want to try and talk about something that people talked about yesterday, you basically can't. And it's just not very well made for this kind of in-depth discussion purpose, right?
And so what about Stack Overflow or Quora?
And so in comparison to Stack Overflow, Quora, Stack Overflow, those are just question answer sites, right? They don't want a sort of more open-ended discussions, right? You don't feel like you're part of the React community just because you answer questions or ask questions about React on Stack Overflow, right? You're just there to get help, and then you leave again. And so Spectrum is sort of this, mine and Bryn and Brian, my two co-founders, sort of take on what we think online communities should be, which is basically a mixture between chat and the forum, where you have posts like you have in a forum. So every conversation is threaded by default. Every conversation that you have has its own place, and you can refer back to old threads, and you can talk about them, and they have some sort of topic. And then the sort of comments underneath it, I put that under air quotes, the sort of comments underneath it are real-time chat. So it has this mixture of, it's good for long-form discussion because the discussions don't get lost after a day, right? They're not gone. They are still at the link. You can just visit the conversation from 2 years ago. Well, not 2 years ago because we weren't around, but from 8 months ago, and it'll still be there. And then because it's real-time chat, it still feels like people are in the room. It still feels like there's warm bodies around. And yeah.
So what's the difference between? So I've messed around with Spectrum. I've used it a little bit. It's sort of like if you imagine like Slack, but instead of making channels, you just make new threads. And because the problem with Slack is that it's built in a way where the channels that you create are supposed to persist over time, whereas in Spectrum, it feels like there's less pressure to think long-term about the channels that you're starting, because you're just starting threads. And so people can start a thread and then have this forum-style thread that is persistent, but it's also kind of lightweight, because if people stop talking about it, it's going to fade away into the background. Whereas in Slack, you just get this channel bloat where even if nobody's using a channel, it just sticks around.
Yeah. You just described everything much better than I did. Yeah.
Okay.
And I think another important property there is that the threads can still be found, right? Because it's a web app, because it's our first sort of goal was to build a web app, you can actually search for it, right? Like if somebody searches for a styled components question, they might find the conversation that somebody had on Spectrum about their exact problem, and they might be able to solve it. Where on Slack or on Gitter or on Discord, that knowledge is lost forever, right? If at all, these tools have built-in search functions, and those are probably not very great because it's still one long stream of text. But Spectrum, you can just Google it, right? You can Google any conversation that happened on Spectrum, and you'll find it on Google or Bing or whatever search engine you use. So the knowledge doesn't get lost forever.
Now, so as a user, so if I'm a user and I go to Spectrum, am I typically going to Spectrum because I have intent? Like, am I going to Spectrum and saying, I want to find, information about styled components. I want to find the answer to a specific question around styled components. Or are people going there with just like I'm going to Hacker News, or I'm going to Facebook because I'm bored and I'm just looking for some jolt of adrenaline?
I think it's both. I think what makes it different from Stack Overflow is that it's both, right? You can go there and you can just ask a question, but then because it's real time, you suddenly feel like you're in a conversation and you feel like you want to stick around. And then our goal is that people want to come back, right? Even if they don't necessarily have a question, they just want to come back and hang out and chat with other people who use styled components. Even if it's not necessarily about styled components, they just want to talk about something, right? And sort of make it feel like it's their place to be. As a user also, it's kind of nice because you don't have 15 different logins. It's one login and it's all of your communities, which is pretty great.
Yeah. Well, I mean, I guess that's another issue with discourse. Well, some people might call it an issue, is discourse has never really become like a networked multi-forum, but I guess that's okay. It was built to be a narrow, specific forum. I don't mean to insult discourse at all. It's very useful. Plenty of people use it. It is fantastic for what it's meant to do. It's not a real-time chat platform. It's a forum. So Spectrum, it's this real-time chat. I guess if people, if you get a chance, just check it out real quick so you can understand what we're talking about here. Because I'd like to discuss the tech stack now. So you've got basically a platform that is like a real-time chat forum. So it's going to have similar architectural issues as a forum, similar architectural issues as a Slack type of application. Describe the tech stack for Spectrum.
I'll start with the backend because that's more of a question. We use Rethink DB as our main database, as our main persistence layer, because of its really nice real-time features, I guess. We use GraphQL for our API, and we use Node.js on the backend just because we're 3 JavaScript developers, so that was kind of an obvious choice. And then we use Redis for some job stuff. And then on the front end, we use React, and we use obviously GraphQL again, because you have to use a GraphQL client if you want to query GraphQL. We use style components, obviously. We use Redux. That's sort of the course overview, I guess.
Now, Rethink DB gives you like push, basically like explain why you use Rethink DB, because that's a differentiated aspect of your architecture.
Yeah, so Rethink DB is built for real time. So they have this concept of change feeds, where you can take basically any query you want and in real time listen to changes to it, which is perfect for a chat app because we can just listen to changes on anything and everything, right? So we have change feeds for new messages in threads. We have change feeds for new threads in communities. We have change feeds for, basically everything, notifications, messages, online statuses, all sorts of stuff. And we don't have to have a separate layer that we use just for real time. So, for example, a common architecture to architect something in real time would be to have Postgres as a persistence layer and then use Redis for real-time notifications. But Rethink DB just does both in one, right? It also has very nice JavaScript support. It works super well with Node.js. It works very well with sharding and replication. So it just overall is a nice database. And we decided to use it, and it's been fairly great so far.
So the change feed is pushing changes to... Is there the GraphQL server? In the GraphQL server?
Yes,
okay.
Exactly. So in the GraphQL server, we just have change feeds on, for example, a new message. And then whenever a new message comes in, we use subscribe via GraphQL subscriptions, and then the subscription just sends down the new message.
Mm-hmm. Is there any concern around using Rethink DB because the company that was built around Rethink DB doesn't really exist anymore? I'm sure you've gotten this question before. I've just got to ask it anyway.
Of course. A lot of people might not know. So this is a very common question I get when I say I use Rethink DB. People go, wait, didn't they shut down? But thankfully, the Rethink DB, the IP was acquired by the Linux Foundation, and it's still very, very actively developed. The open source community just took it and ran with it, right? And it's still under very heavy development. Since the last version, there have been I think 1,000 commits now. It's under very, very active development. So the only thing that doesn't exist anymore is the enterprise support for it, which, to be honest, I don't really care about anyway. So am I sad that the company shut down? Yes, because it's a great database. I would have loved to see somebody with a great database make an awesome company out of it. Unfortunately, they didn't quite succeed. But the great database still exists. And
I believe Slava and most of the team, or some of the team, went to Stripe. So, they're going to get rich anyway.
Yes.
Do you know if that team are they still involved with Rethink DB? Is the core team, the original core team, still hacking on it?
As far as I know, they're still around, but I don't think they work in it. Obviously, I don't think they work in it as often as they used to before. Okay. I think it's mainly just a community-driven project at this point.
Speaking of companies that didn't really succeed in their original open source mission, but have seen some success anyway, the Meteor company, the company built around the Meteor framework, didn't exactly pan out in terms of Meteor, although, I got to say, I used Meteor and it was awesome. It just kind of was... Meteor is such an interesting story because I guess it came up around the same time that React was becoming popular, and there was just so much churn in the front-end world, and they just kind of circumstantially, things didn't work out for Meteor, and then the Meteor company ended up pivoting to focusing on GraphQL, and you use the Apollo toolchain, which comes out of the company that was Meteor and is now, I think, called Apollo. Yep. Maybe, why don't you actually, I wasn't planning to ask this, but why don't you give your perspective? What happened with Meteor? When you think about it from a historical context of how front-end development evolved. What went on with Meteor? Why didn't it work out?
That's a good question. I don't know any inside stories there. I think it was just monolithic in an era where people tried to get more modular.
Yeah.
Right? When you chose Meteor, you chose a whole stack. You chose everything, and you couldn't really get out of it, right? You couldn't just replace a part of it. You used Meteor or you didn't.
And people didn't want a new Rails.
Yeah, exactly. So I guess it was sort of like Rails except for JavaScript, right? I guess that's actually not too bad of a parallel to draw. Except in JavaScript, everybody nowadays has everything in modular pieces, right? I think that's a big reason why React succeeded is because it doesn't do much, and then the community sort of stepped up and innovated around React, right? Where something like styled components would have never happened in a monolithic system like Meteor because I would have just never had the idea to make it, right? It would have just never happened. I think that's one of the big reasons that Meteor, even though it's a great system, I think the whole stack is pretty great. And I'm sure people that use it love it. It just did the right thing at the wrong time. If it did that 5 years earlier, I think it would have been mind-bogglingly awesome.
Do you have a product that is sold to software engineers? Are you looking to hire software engineers? Become a sponsor of Software Engineering Daily and support the show while getting your company into the ears of 24,000 developers around the world. Developers listen to Software Engineering Daily to find out about the latest strategies and tools for building software. Send me an email to find out more. Jeff@softwareengineeringdaily.com. The sponsors of Software Engineering Daily make this show possible, and I have enjoyed advertising for some of the brands that I personally love using in my software projects. If you're curious about becoming a sponsor, send me an email, or email your marketing director and tell them that they should send me an email. Jeff@softwareengineeringdaily.com. Thanks as always for listening and supporting the show, and let's get on with the show. So what is the Apollo toolchain? This is what the company that was formerly called Meteor, I believe it's now called Apollo. It's the thing that they're focused on. And Apollo is this toolchain around GraphQL. What does the Apollo toolchain give you?
So we use the entire Apollo toolchain. The nice thing about it is that Facebook, as they did with React, they sort of released GraphQL as a standalone thing. They released GraphQL, the JavaScript library, a reference implementation. And then they released Data Loader, which is just use GraphQL. But most of the rest of the things were sort of left out in the open. And then there was Relay, which is a client-side library that you use to query GraphQL. But it sort of, they left many things up in the open, right? Like how do you do caching? How do you do performance analysis? How do you... There were just a bunch of things around GraphQL that weren't built out. And Apollo just pivoted from Meteor to GraphQL, at least that's as far as I know, and just built all of the tooling around GraphQL that you could need. And so now they have a server implementation, which is called GraphQL Express, where you can just add GraphQL to an Express server in like 2 lines of code. And then they have this tooling called GraphQL Tools, which is sort of a collection of tools, as the name suggests, around GraphQL, so that you can write them using the schema language, and you can have your resolvers separately. You don't have to use the standard sort of a bit annoying object notation. And then they have Apollo Client, which is a client-side replacement for Relay, that a lot of people really like because it just was sort of influenced by Relay, but made it, I don't want to say better, but they had some different opinions that worked out very well. And now with Apollo Client 2.0, everything is again more modular, and you can plug together your own client, and you can have better cache implementations and all sorts of stuff. And so overall, it's just a tool chain, an open source tool chain to own that sort of covers the whole stack if you want to use GraphQL. And I think for the company, their goal or their idea is to own the entire stack of building something with GraphQL and then building commercial tooling around that and giving you enterprise support and giving you this tool called Engine, which does caching and performance analysis and giving you error tracking and giving you, the sort of more SaaS-style enhancements that you would have on top of any production API. And they just give you that and you pay for it.
So I want to switch back to talking about Spectrum more broadly. I look at Spectrum and I see a big, complicated web app like a Facebook or a Slack or a Quora type of thing, is it hard to find memory leaks in a complicated front-end app?
I hate that you asked that because we actually have a memory leak, and I have been trying to find it for the past 2 days. Yes, the answer is yes. The problem is that with Spectrum...
By the way, I ask because I get memory leaks in even small apps and complicated apps. So.
Spectrum has gotten, over the past 8 months, a very complicated front-end application that does a lot of things. And so it's just organically grown into somewhat of a ball of mud. As much as we try to structure everything properly and like architect it very well, we don't have a set plan for what we want Spectrum to look like in a year or even 6 or even a month, right? Like we're constantly experimenting tones. And so when you're experimenting and moving as fast as we do, it's sort of very hard to stop and reconsider how you're structuring something because you just want to ship it because you have no idea if users are going to like it, right? Like we've shipped several things that we've had to scrap again because we realized, no, they're actually not what we want. And so...
and how important is testing in that process?
We've started doing testing.
Okay.
I'm going to say we've started doing testing, and we use static typing. We use flow type for our...
Okay.
Both for the front end and for the back end. More so for the back end because it really helps there. It really helps us make sure we don't have any annoying bugs, and it's multiple times already caught bugs that would have otherwise been introduced. We also test our backend API a bit, and we've started doing end-to-end testing for the front end. But again, because we constantly change what things look like, it's sort of very hard to... Because you don't want to test implementation details, right? Like I don't want to test that specific component because I know that in the next month that component might look just totally different. So for us, it doesn't really make sense to test a specific component. But it also is kind of tedious to test everything because if you run an end-to-end test, what exactly do you verify? Right? Like where do you even start? Like you do want to know some things very specifically, but you also want to know more broadly, does the app work, right? And so we use end-to-end tests for most of our views just to verify that, basic things are displayed, like that when you visit a community, you see a list of threads and you see the member count and stuff like that, just to make sure we don't break sort of the broad usage. Unfortunately, it means that we have quite a few buggy parts in our app, but that's just the way it is when you... I feel like, so this whole design system, pattern library ideology or sort of philosophy is super great when you have a specific plan for what you're trying to do, right? And the caveat to it is that it restricts you. By restricting to a common set of components, you're sort of restricted in what you can do. Because obviously you can keep adding more components, but if you keep adding more components, you end up with a mess again. And so we have a set of sort of common components, but then we also very often just have ad hoc components because we're trying something new or because it's just easier in that case. And so over time, the code base just has gotten not as nice as I would like it to be, as it always is.
Yeah. Well, rules were made to be broken.
Yeah. I think it's a matter of practicality, right? Like we don't know how long, like we just want to figure out, well, like we don't even know what we're building. Well, we know what we're building, right, but we don't know specifically, right? Like we don't know what sort of the ideal community platform looks like. We have some broad ideas and we're trying to experiment towards a good solution, but obviously we're very far from it, right? We have a lot of experimentation in front of us. And so it doesn't make sense for us to just restrict ourselves to a single set of components and then never change anything because it's unrealistic. Like we're not going to hit the perfect community platform on first try, right? We're going to keep iterating, keep changing things. And so that unfortunately had the side effect that our code base is a bit messy at the moment, which is why I've been trying to figure out why we have a memory leak. Because we use server-side rendering, and so our server keeps crashing because we have a memory leak in our front end, which is kind of annoying.
Yeah, well, I'm sure you'll figure it out. And
of course.
That's. I respect your decision to move fast and develop memory leaks. I have the same philosophy. I want to talk about some more broad topics. It's 2017. How do React and Angular and Vue compare today? I realize you're mostly working in React, but you've got your ear to the ground of the front-end community. What's your perspective on these other ecosystems? Let's
start with Vue. Vue is very interesting because I think it takes the ideas that React had and makes them accomplish a similar thing in a slightly different manner. And it works, I think, very nicely. I think if you know how Vue works, it works pretty well. It's very similar to React. I would probably at the moment not choose it for building a production application. A, because obviously I know React inside and out, but also because it's just not as mature yet. But I think that due to their focus on a low learning curve, they're going to keep growing. And I think Vue will be a very dominant player in the coming years. React has, I think, become the default choice if you want to build any sort of dynamic web application nowadays. At least, maybe that's just my bubble speaking. Maybe I'm just inside of a huge filter bubble. But to me, it seems like you likely choose React today if you were going to build anything sort of complex, dynamic, web app, progressive web app thingy. And then Angular, I think, is interesting because it's contrary to React, and I also think Vue, Angular is very monolithic again, right? Angular does everything, and it does everything out of the box, where React really does nothing or a very limited set of things, and then you have to plug together your own stack based on which state management you want, how you want to fetch data, and all sorts of stuff. I still think Angular, especially with Angular 2 and now 4 and 5, went in a good direction with changing to a more component-based model. It's very widely used still. I don't know, again, this might be my filter bubble speaking, but I don't know many people that would choose Angular over React today, except those that really know Angular. Mm-hmm. But again, maybe that's just my filter bubble because I hang out around React developers all the time. That's totally possible.
Mm-hmm. Well, so we are using Vue for this new site that we're building for Software Engineering Daily. It's called softwaredaily.com. And the big penalty that I have seen so far, I mean, this is basically my first developed front-end app, like very significantly developed front-end app. And I've had a really easy time learning Vue. I've really enjoyed it just because of the same reason what you said, the easy onboarding. And, some of these more complex topics like, the Redux style store, I was so confused by them until I saw them in the context of Vue, and Vue really simplified this data flow and all the code management that goes along with a modern front-end app. But again, the big penalty that we've paid is you can't take very many Vue components off the shelf because there just aren't many. Like with React, like let's take the example of a media player. Like this is a podcast, so we wanted to develop this, like an audio player that you could use in the browser. React probably has 50 of those that you can take off the shelf and import into your app. Vue had 2 or 3, and one of them was kind of buggy. Another one we had to manipulate a little bit. Are there any other penalties for using Vue? Because you were saying there's, maybe it's not ready for production yet. What is it that makes you say that?
I think the library I want to call it the library or the framework itself is ready for production. I think it's just that the ecosystem and community around React is just unparalleled, right? Whatever you look for, you find 50 different implementations for it, which is good and bad because you have to choose between them, but it's good because it saves you a lot of work, right? Like if you were searching for a media player, you'd probably find 50 different media player implementations, and one of them will probably fit your purpose. And that's pretty great. And if you have a question, you can just go on Stack Overflow, and there's, I don't know, there must be hundreds of thousands of questions by now about React, and you can just, somebody's probably had the problem before that you're having. And I think that's a good thing, right? I think that can't go wrong with React, but I also think that Vue has currently at least has a leg up on React in terms of the onboarding and the learning curve and stuff. As you say, it's easy to learn. Like there's nothing, it doesn't feel very complex. And I think they've sort of proven that you can build something similar to React in a way that makes it much easier to understand.
Okay. So last question. I follow Pete Hunt on Twitter, and he's been tweeting a lot about WebAssembly recently. We've done a few shows about WebAssembly, but Pete Hunt is tweeting very excitedly about WebAssembly. What's the state of WebAssembly, and what does WebAssembly enable on the front end? What are we going to see from it in the near future?
I think the most interesting implication is that you can write languages other than JavaScript and run them in the browser. Because those languages might have different trade-offs, right? JavaScript is a very flexible language. It does lots of things, but it doesn't excel at any, right? Like you can program JavaScript functionally, you can program JavaScript object-oriented, you can program, like it sort of depends on what you want to do, which is nice, but it's also kind of annoying. And it doesn't have static typing, for example. So like there's, different languages have different trade-offs. And we have compiled to JavaScript languages like Elm and Reason and ClojureScript and a bunch of others that let you write your code in a different language and then compile down to JavaScript with the same sort of compiler type safety and functional style as the original languages. But imagine what you could optimize if you could run those languages natively, right? That would enable, I think, a whole new class of optimizations where the browser could suddenly apply type optimizations and what have you from all the much more mature languages that have types. And every user could be running them in the browser without having to have this intermediary representation of JavaScript in the middle. I think that's very exciting. And I think, as far as I know, the one missing part there is that you can't access the DOM from WebAssembly, at least as far as I know. And so you probably won't be seeing React being re-implemented in C++ anytime in the near future. But it's exciting. I mean, I think it's going to change the way the web works, really. And I don't think that's an overstatement to say, because suddenly you're no longer restricted to 3 languages. You can write any language you want.
Okay. Well, Max, I want to thank you for taking the time to come on the show, and I'm really looking forward to seeing how Spectrum evolves.
Thank you for having me.
Digitalocean Spaces gives you simple object storage with a beautiful user interface. You need an easy way to host objects like images and videos. Your users need to upload objects like PDFs and music files. DigitalOcean built Spaces because every application uses object storage. Spaces simplifies object storage with automatic scalability, reliability, and low cost. But the user interface takes it over the top. I've built a lot of web applications, and I always use some kind of object storage. The other object storage dashboards that I've used are confusing, they're painful, and they feel like they were built 10 years ago. DigitalOcean Spaces is modern object storage with a modern UI that you will love to use. It's like the UI for Dropbox, but with the pricing of a raw object storage. I almost want to use it like a consumer product. To try DigitalOcean Spaces, go to do.co/sedaily and get 2 months of Spaces plus a $10 credit to use on any other DigitalOcean products. You get this credit even if you have been with DigitalOcean for a while. You can spend it on Spaces or you can spend it on anything else in DigitalOcean, and it's a nice added bonus just for trying out Spaces. The pricing is simple. $5 per month, which includes 250 gigabytes of storage and 1 terabyte of outbound bandwidth. There are no costs per request, and additional storage is priced at the lowest rate available, just a cent per gigabyte transferred and 2 cents per gigabyte stored. There won't be any surprises on your bill. DigitalOcean simplifies the cloud. They look for every opportunity to remove friction from a developer's experience. I'm already using DigitalOcean Spaces to host music and video files for a product that I'm building, and I love it. I think you will too. Check it out at do.co/sedaily and get that free $10 credit in addition to 2 months of Spaces for free. That's do.co/sedaily.
Wow!